Hello everybody, my name is Mike Thompson from the Epic Flight Academy in beautiful New Smyrna Beach, Florida. The private pilot course consists of 3 parts. We have our online learning program, these accompanying videos, and thirdly, consultation one-on-one with your flight instructor. This is the Private Pilot Ground School, and our topic for today is oil systems. Let's take a look at our aircraft oil systems. Well, why do we need oil in the first place? Seems kind of obvious. It reduces friction. That's lubrication. We've got parts rubbing together inside this engine, and the oil lubricates that and makes it, easy for those parts to move against each other, reducing friction. Well, that's not the only thing that oil does. In addition to lubrication, oil provides cooling properties. It also provides a means to carry contaminants through the system to the filter, where they're trapped in the filter. Oil also provides some sealing properties. Now, as you learn more about engines, you're going to learn about parts in the engines where we need to make some seals, and we use oil to help make those seals. So, oil provides many different functions. The 2 primary functions are lubrication and cooling. When we look at oil systems in aircraft, we divide them broadly into 2 categories. We refer to these as dry sump and wet sump. We're going to talk much less about dry sump systems. Dry sump systems are more common in advanced high power engines and in turbine engines. In an earlier video, we talked about the 4 types of turbines. Turbine engines have dry sump systems. Our aircraft, the Cessna 172, has a wet sump system. What that means is there's a sump on the bottom of this engine that's holding the engine oil. And oil inside that engine finds its way back to that sump by gravity. A lot of the insides of that engine are lubricated by what we call splash and spray. And that's exactly what it is. Oil's just kind of splashing and sloshing and spraying around all over the inside of this engine. Hence the term wet and wet sump system. Now here we have a depiction of the oil system. And I want you to understand this is a bird's eye view. You see the propeller up here at the top and the 4 cylinders. Depicted at the bottom here is the sump. The oil travels from the sump by way of the pump to the filter, and then an oil cooler, and then through a relief valve. From the relief valve, it travels into the engine, and it lubricates all the necessary parts, and then by gravity, splash and spray, drops back into the sump, where the cycle starts all over again. Now, to help pilots monitor the oil system, we use primarily 2 gauges. Those gauges are oil temperature and oil pressure. The oil pressure is built up inside the engine by resistance to that oil flow. The oil pressure is not built by the oil pump. That's a common misconception. The oil pump moves the oil, and more downstream constrictions inside the engine or higher RPMs cause more resistance to flow, and pressure goes up. Less downstream constrictions or lower RPM provides less resistance, and oil pressure goes down. In any case, this pump here, it's just turning and burning. It's just moving fluid. It doesn't know what the pressure is. The oil pressure relief valve helps maintain the oil pressure inside the engine within a required range required by that engine manufacturer. That oil pressure range shows up on our oil pressure gauge. Now, in the 172, if you're flying the S model with the G1000, you're going to see a stack of engine instruments on the left side of the multi-function display, or MFD. On the left-hand side of that MFD, you're going to see oil pressure and oil temperature. Well, folks, that is oil systems in a nutshell, and here's our question for today. Does an oil pump make pressure, or is it just a fluid mover? Well, think about that, and we'll see you next time.